Hello everyone, today we're going to be talking about transformations of exponential and logarithmic functions. So we've seen this chart multiple times, but we have these basic transformations. First is a horizontal transformation, so that's when the graph shifts left or right. My function notation for that looks like f of x minus h. So for example, in exponential, if I have 4 to the x minus 3, that would be saying this is going 3 units right. And in logarithmic form, if I had log of x plus 7, this would be saying this is going 7 units left. So we need to remember this is kind of opposite what we think. If you have a minus a number, that's going right. If you have a plus a number, it's going left. Then we have vertical translation, and that shifts the graph up or down. In function notation, that looks like f of x plus k. So an example here is 4 to x plus 5. That would mean it's going 5 units up. And then we have log of x minus 1. This would be going 1 unit down. A reflection is when the graph flips over the x or y axis. So f of negative x, that would be a reflection in the y-axis. And negative f of x would be in the x-axis. So here, for example, 4 to the negative x, that would be a reflection in the y-axis. And then g of x is equal to negative log of x, that would be a reflection in the x-axis. Then we have a horizontal stretch or shrink, and that is where the graph stretches away from or shrinks towards the y-axis. And that would be f of a of x. And remember, if a is greater than 1, then this is going to be a shrink. And if a is between 0 and 1, this is going to be a stretch. So for example, with g of x is equal to 4 raised to the 2x, this would be a shrink by a factor of 1/2. So remember, with that horizontal, you're going to take the number that you see here, which is your a, so a here is 2, and you're going to take the reciprocal of that. So it's going to be 1/2. Where for this one, log of 1/3 x, this would be a stretch by a factor of 3. Because again, we take that reciprocal, so I flip the 1/3 to become 3. And then vertical stretch or shrink is when the graph stretches away from or shrinks toward the x-axis. And so this is going to look like a times f of x. So here, if a is greater than 1, that's a stretch. And if a is between 0 and 1, that is a shrink. So for example, 3 times 4 raised to the x, that would be a stretch by a factor of 3. And then g of x is equal to 2/3 log of x, that would be a shrink by a factor of 2/3. So let's look at some examples of transforming exponential functions. So here we're going to describe the transformation of f represented by g. First, I have f of x is equal to 1/2 to the x, and g of x is equal to 1/2 to the x minus 4. And so I see I have my function f in here. The only thing that changed was that minus 4, and that is my k. And remember, with subtracting or adding at the end, that's a vertical translation. So I would say that this is a translation 4 units down. Okay, this next one, I have my parent function is f of x is equal to e to the x, and then g of x is equal to e to the x plus 3 plus 2. So I see here what changed was that plus 3 and that plus 2. So that plus 3 is my h, and the plus 2 is my k. Now remember, with it being plus 3 with that x, when it's a plus in there, that means it's going to the left, just like this log of x plus 7. So I would say this is a translation 3 units left And that plus 2 means it's going up 2. So I say 2 units up. Okay, number 3, I have f of x is equal to 3 to the x, and then g of x is equal to 3 to the 3x minus 5. So I see here I have an h, that minus 5, and now I also have a number in front of x, so that is my a. Now since it is with my x, it's not being multiplied out in front, this is going to be a horizontal stretch or shrink. Since a is bigger than 1, this is a horizontal shrink. So I can say this is first a translation 5 units right, and a horizontal shrink by a factor of 1/3. So you take your a, which here is 3, and then you're going to do the reciprocal of it. Okay, let's look at one more. Here I have f of x is equal to e to the negative x, and g of x is equal to negative 1/8 of e to the negative x. Here it's really tempting to see, okay, I have a negative x, so that means this is a reflection of the y-axis. But you need to look at your function that you're starting with. The function I'm starting with, it's already e to the negative x, so that's actually not a transformation that has happened. However, there is this negative out in front, so that is a reflection. And then I have this 1/8, which is my a. So I can say this is a reflection in the x-axis, since there's a negative out in front. And since I'm multiplying the whole function by 1/8, this is a vertical shrink, because it's 1/8. Vertical shrink by a factor of 1/8.